Dear students, in the last class I have explained important term, that is average velocity. The formula is V bar is equal to x2 minus x1 by t2 minus t1. And then I have explained another important point called instantaneous velocity, velocity of a body at a particular instant of time. Now, if you see the animation here, you get to see the speedometer, correct. So, what does speedometer of a car record? The speedometer of a car basically records instantaneous speed, correct. So, as the car moves, the pointer there, it varies continuously. So, this is a analog meter. So, you get to see even the digital speedometer also. So, speedometer of any automobile always measures the instantaneous speed. So, let us learn more about an important term called acceleration. When do we say that a body is accelerated? A body is said to be accelerated when there is a change in its magnitude of the velocity. Whenever there is a change in magnitude of velocity, or whenever there is a change in a direction, whenever there is a change in direction, or whenever there is a change in magnitude and direction of velocity. So, in all these three cases we say that the body has acceleration, that is whenever there is a change in magnitude of the velocity. Example for the first case, case 1, freely falling body. Okay. So, when a body falls freely, its direction is a constant, but its a value, velocity, magnitude continuously increases, correct. So, when you take a chalk here, right now its velocity is 0, and when I leave that, it's a continuously, its a magnitude changes, we say that the body has acceleration. Change in the direction, case number 2. When a body moves in the circular path like this, there is a continuous change in direction, correct. So, even in this case we say that the body has acceleration. Change in magnitude and direction. Example for the third case, you take example of an oscillating pendulum. So, here its velocity or magnitude continuously changes, it becomes 0 and again it comes back like this, changing the direction. Therefore, in the case of oscillating pendulum, again there is acceleration because there is change in both magnitude as well as direction. So, in three different cases we say that the body has acceleration. Whenever there is change in magnitude, whenever there is a change in direction, and whenever there is a change in magnitude as well as direction. But we are learning about the change in magnitude only in this particular chapter, because this chapter is related to motion of a body along a straight line where the direction is fixed. So, since the direction is fixed here, we don't study, we are going to study this later in some other chapter. So, therefore, let us stick on to the first case only. So, how to measure the acceleration when there is change in magnitude. Change in magnitude. What do you mean by change in magnitude? So, velocity has to be same. It cannot be uniform velocity. If the uniform velocity means that the velocity remains same. When the velocity is uniform, the acceleration is 0. There is no acceleration, because we say that a body is accelerated when there is a change in velocity. So, let us consider u is the initial velocity, and this velocity changes to v, and this is the final velocity. U is the initial velocity when time t is equal to 0, and v is the final velocity after a time t. So, now what is the change in velocity? The change in velocity is final minus initial, which is v minus u. This is the change in velocity, and this change takes place in a time t second. T minus 0 is nothing but t. So, therefore, acceleration is defined as a rate of change of velocity. So, A is the symbol used for that. So, how do we define acceleration? Acceleration is defined as a rate of change of velocity. It's called acceleration. What do you mean by a rate? A rate means always with respect to time. So, therefore, the formula for acceleration is change in velocity divided by time. You know, that is the meaning of the word rate with respect to time. So, this is one of the formula which is used to find the acceleration. So, acceleration is defined as a rate of change of velocity. This is the change of velocity. When you divide by time, it becomes the rate of change of velocity. What is the SI unit? Velocity is measured in meter per second in the numerator, correct? Divide by again time, another second. They don't get cancel each other, correct? So, you will get meter per second square is the SI unit of acceleration. Velocity is a vector. So, definitely acceleration is also a vector quantity. What is the dimensional formula? Meter, the symbol that we use is L. Second, the symbol that we use is a T to the power minus 2. So, this is the dimensional formula of acceleration. Acceleration is either positive, negative or 0. So, when acceleration is positive when velocity increases. If the final velocity is more than the initial velocity, then the acceleration is positive. So, when the velocity increases, acceleration is positive. Good example is freely falling body. When acceleration is negative when velocity decreases. You take example of a object thrown upward like this. See, at one point, at the highest point, its velocity decreases and it becomes 0. So, that means when a body is thrown upward, velocity decreases and then it becomes 0. And again it falls back, again velocity increases. So, therefore, whenever velocity decreases, acceleration is always negative. A negative acceleration is called retardation, or it's also called as a deceleration. Negative acceleration is called retardation or deceleration. If a vehicle is moving and if the brake is applied suddenly, that is deceleration, because the velocity decreases and then it becomes 0. Are you clear? And when acceleration is 0, when the body moves with uniform velocity. There is no change in velocity. See, this change in velocity becomes 0. That is why acceleration also becomes 0. So, acceleration is positive, acceleration is negative, acceleration is 0. Positive acceleration, good example, freely falling body. Negative acceleration, good example, body thrown vertically upward. And 0 acceleration, a body moving with uniform velocity, correct? If a vehicle moves with uniform, same velocity, no change, then 0 acceleration, right? Okay. So, acceleration is a vector, SI unit is meter per second square, LT minus 2 is the dimensional formula of acceleration. And how do we define acceleration? Rate of change of velocity is called acceleration. Now, you can see this question they have asked in the exam, define acceleration. So, how to define acceleration? A rate of change of velocity is called acceleration. Next, we have an important term called uniform acceleration. Uniform acceleration. So, to understand that, let us take the illustration of this animation. Okay. Uniform acceleration. Now, what do you mean by uniform acceleration? Uniform acceleration means if velocity changes by equal amount in equal interval of time. Okay. If the velocity changes by equal amount in equal intervals of time. Velocity, let us take 10 meter per second, then it becomes a 20 meter per second, then it becomes a 30 meter per second. So, from 10 to 20 it takes 2 seconds, from 20 to 30 again it takes 2 seconds. So, velocity changes, there has to be change in the velocity, because if the velocity does not change then the acceleration is 0, correct. So, velocity changes, how much, what is the change here? Change is at 10. What is the change here? Again 10. So, like this, okay. Changes by equal amount in equal intervals of time, see. So, this change takes place in 2 seconds, next again in 2 seconds and so on. Then we say that the acceleration is uniform, and good example is freely falling body. A body falls freely under uniform acceleration, and that acceleration is called acceleration due to gravity. And in this illustration, see, acceleration is fixed 1 meter per second square, but you can see the velocity is changing. It is a 3 meter per second, okay, and now it becomes a 4 meter per second. See, velocity continuously changes, but acceleration is fixed. Hope you can see that. And then finally, the brakes are applied so that the car comes to rest. So, hope you have understood. So, fixed acceleration, but velocity continuously changes. How it changes? Equal amount in equal intervals of time, the acceleration changes, that is uniformly. Okay. So, that is about the uniform acceleration. So, hope the important term is clear to you all. So, a term acceleration which is used in number of chapters, so very important physical quantity, especially in motion of a body. How to define average acceleration? See, we know average velocity, correct? So, first let me write the formula for average velocity. V bar is equal to x2 minus x1 by t2 minus t1. This is how we measure average velocity. Now, the average acceleration is equal to the total change in the velocity, which is v2 minus v1, by the total time taken, which is a t2 minus t1. So, this is how you get it. Are you clear? So, this is average velocity. This is average acceleration. Total displacement to the total time taken. Total change in velocity to the total time taken for it. Okay. Next, we have instantaneous acceleration. So, how do you measure instantaneous velocity? A very small change in the distance or displacement to the time taken for it will give you the instantaneous velocity. And instantaneous acceleration is acceleration of a body at a particular instant of time, which is given by a small change in the velocity to the corresponding change in the time. So, v is equal to dx by dt, a is equal to dv by dt. So, that is how you get the formula. So, all the four formulas are important: average velocity, average acceleration, instantaneous velocity, instantaneous acceleration. So, hope you are clear with all these formulas. So, be thorough with it. In the next class, we are going to solve numericals based on all these equations.